An irrational number is a number that cannot be expressed as a ratio of two integers or as a repeating or terminating decimal. So an irrational number cannot be written as a fraction. And irrational numbers produce decimals that are non-repeating and non-terminating. So they do not repeat. There is no pattern that repeats. And they're non-terminating. They never end. They go on and on and on with no specific repeating pattern. The square root of a number that is not a perfect square is always an irrational number. So for an example, we could have the square root of 2. 2 is not a perfect square. And so if we take the square root of this number, it's going to produce an irrational number. We could have pi. Pi is an irrational number. It is a number that never repeats and never terminates. So any number that you see pi in is going to produce an irrational number. So now that we know what an irrational number is, let's seek to approximate the value of the irrational number. So we're going to estimate or come up with a pretty good guess of where that number is on the number line. We'll take example 1, the square root of 28. Let's approximate it to the nearest tenth. That's what we're going to work on, approximating to the nearest tenth. So step 1, find the whole number whose perfect square is the closest to this irrational number. So look at the number inside the radical, inside the square root. That is the number 28. What perfect square is closest to 28? Well, you could say 25, right? If you take 5 and square it, 5 squared gives you 25. The next perfect square would be 36, and 36 is not as close as 25 is to 28. So the closest whole number, the closest perfect square to 28 would be 25. Step 2, we're going to divide the irrational number, or the number inside the square root. We're going to divide 28 by that whole number from step 1. So the whole number we said was 5. So 28 divided by 5. And we're doing all of this without a calculator. So here we need to divide 28 divided by 5. We need to add placeholder 0. 5 goes into 28 5 times. 5 times 5 is 25. I subtract, bring down the 0, and 5 goes into 30 exactly 6 times. All right, so we get that 28 divided by 5 is equal to 5.6. Okay. Now, step 3, final step here, is to find the average. To find the average, we add up the numbers and divide by 2. Find the average of the quotient and the divisor. So back here, the quotient, right, this, I'll just put a Q for quotient. The quotient is the answer to a division problem. Here was our division problem. This is the answer to it. So that 5.6 is the quotient. All right, and the divisor is the number that we divided by. And this right here is the number we divided by. So I'm going to put, let's put D for divisor. So I need to find the average of these two numbers, the quotient and the divisor. So I'm going to add those numbers up, 5 plus 5.6. I'm going to add them up and divide by 2, and that would give me the average of those numbers. So if I add the numerator, 5 plus 5.6 is 10.6, and I need to divide by 2. So 10.6 divided by 2, decimal goes straight up into the quotient. 2 goes into 10 5 times. 5 times 2 is 10. I subtract and bring down the 6. 2 goes into 6 exactly 3 times. Right, so we get the average of these numbers being 5.3. So that is the approximate value of the square root of 28. We would write the square root of 28 is approximately, it's like the squiggly equal sign, square root of 28 is approximately 5.3. Okay, one more example. We're going to approximate the square root of 50. So first step, what whole number whose perfect square is closest to this irrational number? Well, you should think 7, right? Because if you take 7 squared, you get 49, which is only 1 away from 50. Step 2, divide the irrational number. Divide that number inside the radical. We're going to divide that by that whole number from step 1, which was 7. So we have 50 divided by 7. 50, I'll add placeholder 0, 50 divided by 7. 7 goes into 50 7 times. 7 times 7's 49. I subtract, bring down the 0. 7 goes into 10 one time. 1 times 7 is 7. I subtract 10 minus 7 to be 3, bring down the 0. 7 goes into 30 4 times. Now, this hasn't ended yet. We can keep going, but you should see a little note right here. We need to round to the nearest tenth if needed. And this would be a case where it's needed because the decimal continues to go on. So let's round right here. We're going to round to the nearest tenth. This 4 right here tells us to keep the 1 the same. Not to round up, but to keep this place value the same. So 50 divided by 7 is 7.1. We're going to go ahead and round to the nearest tenth, 7.1. All right, step 3, final step here, is to find the average of the quotient and the divisor. So 7.1, this would be the quotient, 7 was the divisor, right, the number we divided by. We need to find the average of these two numbers, 7 and 7.1. So to find the average of them, I'm going to add them up, 7 plus 7.1, add them up and divide by 2. On the top I have 7 plus 7.1, that's 14.1. And I need to divide by 2. So 14.1 divided by 2. Decimal comes straight up. 2 goes into 14 7 times. 7 times 2 is 14. I subtract and bring down the 1. 2 cannot go into 1. It goes in 0 times. 0 times 2 is 0. I subtract. Got to add a placeholder 0 so I can bring it down. 2 goes into 10 exactly 5 times. So your remainder is 0. So we have 7.05, but remember we want to approximate this to the nearest tenth. And so what this 5 right here tells us is to round the 0 up to a 1. And so we have the square root of 50 is approximately 7.1 or 7 1/10.